your correlation. It's just a fun little graph to play with. So let's put a ball of points here. Okay? And that has got something that's very close to 0. In fact, I could probably get that a little bit closer to 0 here. There's 0.0403. So that's just a random ball of points there. Now what happens to this if I put one single point up here? Look at that. It went from 0.04, almost 0, up to 0.8709. This one point, this outlier up here, had a great effect on it. Put another one up there and it goes up to 0.92, 0.94. So again, it's just a fun little graph that you can use, a little thing that you can go through and put in some points, and you can see how it affects the graph. Let's do one more. Let's put these sort of in a rainbow. Okay? Okay? So you can see that the line sort of goes through here. That's a plot of what the line is. We've got a negative relationship. Now there's obviously a relationship here, sort of like the arm strength example we talked about earlier. But statistically, you know, this would probably not, as you can see, you had to have a 0.3, and it could be positive or negative, with 30 points to even be significant, so this would not be significant. Okay? So that's a fun one to play with, and you might try that sometime. Okay. So let me go back over here to the document camera. Hopefully that's where we are. If R is statistically equal to 0, then we should not use the formula to make predictions. Okay? If the formula is not significant, then it's not any use to us. So if the R is not significant, don't use the formula. And you may have some test questions on that. Also, stay within the data when you make predictions. So if we were going to go through, and let's just say that we were going to plot the number of hours that a student studies with their grade. And so we go through and we find out that the grades go from 0 to 100. And here's the number of hours. And 1, 2, 3, 4. And we find that there's something like this. If they don't study, they make a 0. If they study 4 hours, then they make 100. And we find that there's a statistical relationship there. Okay, don't go and predict beyond this. So someone says, well, okay, if they study 4 hours and they make 100, then, I'm going to put this in red because this means don't do it. What happens if they go and they study, then if you go through and you get a formula, y is equal to the number of hours studied, 4 times, basically 25 points. So it'd be 25 times the number of hours studied. So someone goes through and they say, well, okay, if that's true, if that relationship exists, then I want to study 6 hours. Well, that would mean that they would go up and they would get 150 points on the test. Well, the test is set up so that 100 is the maximum, and so you can't predict beyond where your graph or where your formula is based on the original data. But you'll see that people do this, although this looks like a trivial example, you'll see that people do this often in the literature and in the real world. Don't use old data. You know, for example, right now we're in daylight savings time in the United States. That was, you know, moved up 3 weeks in March of 2008. But the reasoning was based largely on a 30-year-old study out of Australia. And so they go through and they apply it to a different country, they apply it to a different time. I'm not really sure that that was a useful thing to do. And so, and just some points to go through as you use these correlation and regression. Be careful what you're doing and stay within the limits of the correlation and regression. Again, hopefully this has been useful. And if you have questions, let me know. Thank you very much. Okay, that concludes that session. I do want to add a couple of things right here at the end of this. I have just a couple of minutes, and so let me do this. This first one is a type of a test question that you will probably see. And I just made some quick notes right here. If R is 0, now that statistically speaking, I mean R is 0, means it's not significant. That means there's no relationship. So if we go through and we're doing something at the 0.05 level and we have 20 and we get a R value, let me get up here close here. So you've got 20 here, right there. Sorry about that. Moving around. But if we get 20 and we get a p-value that's below the 0.444, we get a p-value that's like 0.3 or something like that, that means that it's not significant. And so sometimes on a test I will ask you, I'll give you a p-value, R value, and it's going to be not significant. And I'll say, here's the formula. X is equal to 5, or Y is equal to 5x plus 9. And I'll give you the average values, the centroid value of X and Y. That's a clue. If you see that, then the red flag should go off. If it's not significant, those are the best predictors. You ignore the formula. You don't pay attention. And then I'll have a question that says, what's the best prediction if X equals 10? Your first indication, your first intuition is probably going to be to plug that into this formula. Plug in X is 10 and you get Y is equal to 59. And that will be the wrong answer. If this formula, if the R value is not significant, then this formula doesn't mean anything. You can calculate it, but it doesn't mean anything. If R value is not significant, these are the best values to use for the prediction. So the answer in this situation would be 9. Okay? And so you need to watch out for that. The other thing that we need to watch out for in correlation and regression is the effect of outliers. And I can't emphasize this enough. You saw several examples where we had a bunch of points down here and 1 point up here. And that makes the whole thing significant. Or we have a bunch of points up here and 1 point down here. And that makes it significant. That outlier can have a tremendous effect on it. Or it could be a situation where we have some points like this, a pretty good looking relationship, and 1 point up here. It turns it in from a negative relationship to a positive relationship. So it's very important for you to look at your data and to see what's going on there. Again, as I always end these, I hope this has been useful to you. Give me feedback. If it's not helpful, then I can add to it or whatever. So have a good day.